Hi class, we are starting on the second lesson of this unit, and this one is about solving equations. So we're going to start learning how to solve equations that are a little bit harder than what we did in the last couple of warm-ups. So this first page right here, you're going to actually need three things today. You'll need this page right here, inverse operations. You will need this page right here, which is all of the examples that we're going to use to solve equations. And then you'll need this packet foldable right here, which I will show you how to use in just a minute. But it should be pre-made for you. You might just have already needed to cut along the little things. So we're going to start with this one that says inverse operations. And inverse means to inverse operations mean they're operations that undo each other. So they're the undo operations. For instance, when we talk about inverse operations in real life, we're talking about, like, if I put my shoes and my socks on, first I put my socks on, then I put my shoes on. To undo it, I have to go in the opposite order. So if I had my shoes on already, then I take my shoes off, and then I take my socks off. So taking them off is the opposite of putting them on, and I have to go in the opposite order that I put them on. So let's just talk about inverse operations. Remember, operations are add, subtract, multiply, and divide. So what is the inverse operation to addition? Subtraction. So the opposite of add is to subtract. What is the opposite of multiply? Well, the opposite of multiply is to divide. And before we move on, I want to show you some different ways that you might see multiplying. You might see it as 2.x. You might see it as 2x without the dot in there. And also, you might see it as 2 parentheses x plus 3, because that's the distributive property. Okay? For division, you might see it as the symbol x divided by 2, or you might see it as the symbol x slash 2. Sometimes you see that. Or finally, you might see it as x divided by 2 written like a fraction, where it's x divided by 2. Okay? So for multiplication and division, these are some different ways that you might see that happening to x. Okay? And then the last one we're going to talk about for the last square here is going to be squaring a number. So this would be x squared. And then the square root of a number. The opposite of squaring is taking the square root. We're not going to deal with these two things until Algebra 2 as far as solving equations, but we do need to know that the opposite of squaring a number is taking the square root. That's how I undo squaring a number. Okay, so down here on the bottom, I wanted to talk about what does it represent when it's positive, if it's a plus sign or addition. Okay, so represents addition. So if I see a positive number all alone, that represents addition. So I might see x plus 3, or I might see it as 3 plus x. Either way, that means I'm adding, because the 3 is positive. Okay? Here the 3 is positive. So in both cases, that means that to undo, I'm going to do the opposite of positive 3, which would be negative 3 to both sides. To represent subtraction, that's going to be a negative number by itself. So if I cover up x and see a negative number all alone, then that means I'm going to do subtraction. So to undo it, I would do addition. So if I had x minus 6, if I cover up the x, do you see how that's a negative number all by itself? So that means this is representing subtraction right here. And to undo that, I would do addition. Another way I might see a negative number by itself is if I have negative 6 plus x, because if I cover up the x, do you see how I still have a negative 6? So that still represents subtraction, and to undo it, I'm going to use addition. Okay, so one of the easiest ways to solve is to cover up the x and see is there a number all by itself. And then to represent multiplication, that's the dot. I try not to write multiplication anymore with using an x because we're solving equations. And that's always going to be a number next to a variable. Remember that word, a coefficient? Coefficient that we learned last year, or last unit, I mean? Coefficient. So like we might have 2x, or we could even have a fraction next to x, and that would still represent that multiplication. 2 times x, half times x. Okay? Even though there's not a dot in between them, it still means multiplication. So what we're going to do now is we're going to solve some equations using inverse operations. And so we're really going to focus on, does it represent addition, subtraction, or multiplication? And what do we do to solve it? Okay, so we're now going to use this worksheet here. So example 1, and I might zoom out just a little bit. Okay, so example 1 here. The first thing that you're going to do before you solve any of these equations is you're going to draw a nice wall. Okay, so I like to just put a wall on all of these equations where you see the equal sign. Okay, so before we solve anything, I like to know where exactly is the equal sign. That's going to help me out. So on my paper I've gone through and I have drawn a wall wherever the equal sign is. Remember, the rules of equality mean if I do something on one side, I have to do the exact same thing on the other side of the equation. Also, I have this packet right here, and you can use this to help you solve. So on number 1, and that's the only one we're looking at right now, are there any parentheses? No. So if I answer no, then I pull this open and I read it, and it tells me there are no grouping symbols, go to the next step. So then I say, are there any like terms? Now what this means is I have to have 2 terms that are the same in the same, I'm going to call this a room, and this is another room. So are there any like terms in the same room? No. So I'm going to lift it up to the no section, and it says each side is simplified, no terms can be combined, move on to the next step. The next step is, are there variables on both sides? That means, are there letters on both sides, right? So are there any letters on both sides? No, there's only letters on one side. So I'm good. So the variable is only on one side of the equation. Go to the next step. Then it says, do you have a number being added or subtracted to the variable? So this is where you cover up the variable and you say, do I have something that represents positive and something that represents negative? Yeah, I have a negative, right? -5. So, yes. So what are you going to do? You're going to use inverse operations to remove the number. So, what operation am I going to use to undo -5? Well, to undo -5, I'm going to do +5. So I was subtracting 5, now I'm going to add 5. If I do it to one side, then I have to do it to the other side. And notice what I've been doing this whole time. I've been covering up that 3x, okay? Because I'm not worried about that right now. All I'm worried about is getting the thing that's added or subtracted on x to be canceled out, okay? So now they cancel each other out, and on this side I have 15. 10 plus 5 is 15. And on this side I have 3c. Okay? The last step on our card, do you have a number being multiplied or divided by the variable? Yes, I do. So on that, I'm going to use inverse operations to isolate the variable. Okay? So, I'm being multiplied by 3, so to undo that, I'm going to divide by 3. When you divide by 3, you get 3 over 3, which is 1. So this is C equals, and over here, what is 15 divided by 3? 5. So the answer to example 1 is 5. You're going to do that for every single one of these examples, okay? So let's work through example 2. Example 2 says negative 6 equals 2d minus 4. So you go back to your flip chart and you close up all the flaps and you ask yourself all these questions. If the answers are no, then you really do just move on to the next step. That's what it says each time. So on number 2, are there any parentheses? No. Move on to the next step. Are there any like terms on either side? No. So you move on to the next step. Are there letters on both sides? No. So you move on to the next step. So this is where you cover up the variable and you go, is there a number being added or subtracted on the variable? Yes. This is worth a negative 4 because it's minus 4. So what do I do to undo subtraction? I'm going to do undoing subtraction, that's addition. So I'm going to add 4 to this side. Remember, I'm covering up the letter, okay? I'm trying to keep just the letter covered up at all times. So I add 4, and that's 0. I'm going to come over to the other side, and I'm going to add 4 as well. If I do it on one side, I have to do it on the other side. Draw your wall or your equal sign. 4 minus 4 cancels itself out. And what's negative 6 plus 4? So go to your calculator, and you type negative 6. Remember, the negative 6 is going to be this negative right here. So negative 6, that's what you type. You push this negative button right there. Negative 6 plus 4, and that equals negative 2. So on this side of the wall I have negative 2, and on the other side of the wall I have 2d. And then the last step says to divide or multiply, so I'm going to, it's multiplication, so to undo it I'm going to use division. So d equals, and notice my d is on this side. That's okay. Negative 1. It doesn't matter what side your d is. Try not to reverse it and put the d over here because that just gets really confusing when you have more complicated expressions and equations. Okay, so just leave your d on this side. Alright, example 3. I'm going to go ahead and let you work example 3 on your own and see if you get that one correct. Okay, so if I cover up the g, I have positive 5. To undo positive 5, I'm going to do subtract 5 from both sides. So that gets me 0 right here, and I'm left with 4g on this side, and then on my calculator I type negative 3 plus negative 5. You could also just type negative 3 minus 5, because that means the same thing. Negative 3 minus 5 is negative 8. So 4g equals negative 8, and then you're going to divide by 4 on both sides. So g is equal to negative 2. Alright, example 4. This one's a little bit trickier. What is the first step to solving this problem? Well, make sure that I've got only x's on one side and everything is simplified, which it is. So I'm going to cover up the x part. So it's still the same first step. I'm still going to get rid of the number that's added or subtracted to the problem. So I'm going to add 2 to both sides. And so that cancels out, and I get 5 on this side. And on this side, I have 5 over 8x. What is this fraction doing to x? Well, hidden in between them is a multiplication sign. So, remember on here when we wrote 1/2 x, it's the same here, it's just 5/8. So to undo multiplication, I'm going to do division. So I'm going to divide by 5/8. Okay, that gives me x equals, and I can go to my calculator and I can type 5 divided by, and remember you can make a pretty fraction on your calculator, alpha y equals enter, and then 5/8. So now I have 5 divided by 5/8, and that gets me 8. So x equals 8. And maybe in your notes right here you might put alpha y equals enter to get a fraction. Some of you may need that. Okay? Alright, moving on to the next problem. you do example 5 all by yourself, and we'll come back and grade it in a second. Okay, so cover up the x. So I have to subtract 3 from both sides. So this becomes 2 on this side and 2/3 x on this side. Remember, to solve it with the fraction in front, that's multiplication, I'm going to divide by that fraction. On my calculator, I do 2 divided by alpha y equals enter 2/3, and that gets me 3. So on this problem, x equals 3. Okay? All right. Example 6 is a little bit different. We need to go back to our card. What's different? Well, step 1 always says, are there any parentheses? So what do we do if we see parentheses? So you open this up and you say, oh, I need to use the distributive property to multiply the number outside of the parentheses to every term inside the parentheses. So when I multiply, I get 3 times t, which is 3t, and 3 times 2, which is 6, equals 12. Now, this problem looks just like the rest of them, and you can solve it just the same way. Cover up the 3t, get rid of the 6 by doing subtraction, and I'm left with 3t on this side and 6 on that side. Then divide by 3, and you get t equals 2. Okay? So, anytime you see parentheses, you're always going to take care of that first. Alright, let's look at number 7. Number 7 doesn't have, if I cover up the letter, I have another letter. So what do you think I should do? Well, that's where your chart comes in handy. Are there any like terms? Well, yes, there are. 3b and 5b are like terms. Oh, look, you probably guessed it. You're going to combine the like terms. Okay? So, combine the like terms here. 3b plus 5b is 8b, 8 bananas, equals -4. And then all you do is divide by 8 on both sides. So b equals, and then -4 divided by 8. When you type that on your calculator, you get -1/2. Okay? It's a glare, -1/2, or 0.5. If it's a fraction or a decimal, I don't care unless it says so in the answer choices on your homework. Okay? Alright, so what do we do on example 8? So if we look at example 8, I notice that it's got 4p plus 2 plus p. Can I do anything to that before I start going? Because if I try to cover up the p, I still have a p here. What should I do? Alright, I'm going to put my p's together. So I have 4p, and what's hiding before the other p? Yes, a 1. A 1 is hiding before the other p. So this is 5p plus 2 equals -4. Now what? Well, this looks just like what we started with. Cover up the 5p, get rid of the letter that's on the side with your finger, not the letter, the number, I'm sorry, that's on the side with your finger. So 2 minus 2 cancels out, and I've got 5p on this side. And then you take your calculator and you type -4 minus 2. Do you notice how there's only one minus sign there? I didn't put 2 there because there's only one minus sign here. When we put them together, this becomes one subtraction sign. Okay? So -4 minus 2 is -6. So -5p equals -6. And then what do? Just divide. So p equals, and I'm going to divide that on my calculator, -6 divided by 5, and I get -1.2. Okay? Any questions about number 8? If you do, please stop the video and ask. Alright, number 9. Number 9 is a little bit trickier, but it's just a couple of extra steps. The first thing it says to do is take care of parentheses. So, I'm going to have to cover up everything and just look at that part that deals with the parentheses. So I'll use this to help cover everything up. So what am I going to do? Well, -5 times 3 is -15. And negative 5 times negative 1r is positive 5r. So I've taken care of my parentheses. This does not magically disappear. It stays, so I have to bring it down. Negative 5r equals, and negative 15 stayed as well. I just bring everything down. So that was step 1. I took care of the parentheses. Step 2 is to combine like terms. So are there any like terms? Well, yeah. There's 5r and negative 5r. What do you get when you have 5r and negative 5r? Well, you get 0. So you get negative 15 equals negative 15. And I actually put this one on here on accident. I wasn't going to explain this today, but if I have no letters left in my problem, if they all cancel out on the same side of the equal sign, I'm going to take a look at my numbers. Negative 15 equals negative 15. So down here at the bottom, if everything cancels out, you're going to look at this, do I have a solution? So we have one solution, infinite solutions, or no solutions. So here's the example. If I get one solution, I get x is some number. But if I get 5 is equal to 5, or some same number is equal to its same number, then I'm going to call this infinite many solutions. So this problem right here is infinite solutions. Okay, don't worry about that for your homework tonight. None of them should turn out like that. But the steps are the same. I'm going to distribute, and then I'm going to combine like terms, and then I'm going to get my answer. Okay? Alright, let's look at example 10. Example 10 says 9m minus 6m plus 6. Since there are parentheses, I have to take care of that first. Before I can do anything, I need to know what is before the parentheses. Is the 9m touching the parentheses, or is there something else touching the parentheses? Because there is a subtraction sign right here, there is an imaginary 1 hiding before the parentheses. So I'm going to cover up the 9m, and I'm going to distribute that negative 1 to each term. So this is negative 6m plus 6 equals 3. And the 9m didn't just disappear. Oh, did I mess up? I did. It's not negative 6m plus 6. It's negative 6m times, and then negative 1 times 6. Negative 1 times 6 to get negative 6. Does everybody agree? Does that make sense? Okay, so then 9m on the outside. Now, what do? Now I combine like terms. 9m minus 6m is 3m. So I'm going to put these two terms together, and I'm going to get 3m minus 6 equals 3. And then I have to cover up my m and see if I can get my constant to the other side. So plus 6 and plus 6, and that gets me 9 on this side, 3m on this side, and what do I do left? Divide by 3. So we're going to divide by 3 here and divide by 3 here, and that gets me m equals 3. Okay? Alright, so those are your notes for today. Those are going to go in your spiral on page 13 and 14 and 15. So make sure that you use your spiral to label all of the pages. Here is the table of contents. So page 12 is more examples. Page 13 is going to be inverse operations. Actually, let's do inverse operations and examples. We'll put those together. I'll show you on the video. And page 14 is going to be the flow chart to solving equations. Flow chart for solving. Okay, so let me zoom in on that. Make sure you pause the video if you need to so that you can see the table of contents. Inverse operations and examples, flow chart for solving. Okay? So what you're going to do is you are going to take your examples page and you'll fold it in half. Take your examples page and fold it in half. And then you'll take your inverse operations page and you'll glue it on top. So glue that inverse operations page on top of your examples page. Get your glue stick, glue it down. They should fit pretty exactly. And then this page is going to be glued on this is page 13. So you'll go to page 13 in your spiral. Call this page 13, and you're going to glue down your inverse operations and your examples. All go on the same page in your spiral. Okay. And then on page 14 of your spiral, you'll glue the flowchart, solving equations flowchart. That'll be on page 14. Okay? So once you're done with that, you can grab your homework and you are done for the day. Just work on your homework until it's time to go. Thank you so much. Have a good day.